Taylor polynomials as opposed to Taylor series and remainders. Okay, so first of all, Taylor polynomial is a very simple concept. The Taylor polynomial of degree n centered at a, for the function f is just this. It's just summation k goes from 0 degree to nth degree and stop there, right? So you have all those terms, which is the k derivative, 0th derivative means f itself, right? Of a divided by k factorial multiplied by x minus a to the k's binomial. For example, if you stop here, right? If you truncate here, then this becomes a degree, a polynomial of degree at most 2. Is that right? And that polynomial, the sum of this, is called the Taylor polynomial of degree 2. Okay. And call it denoted by Tn of x. Okay. Then further define the second concept, which is a remainder. So if you have a Tn, then Tn of x is only an approximation of f of x because you truncate it, right? You truncate the series. And so fx is not, Tn is not f of x. So there's a discrepancy. That discrepancy is called Fn of x. And this one is f of x minus Tn of x. I.e., phrase it differently, f of x is equal to Tn of x, not quite, plus a little bit. And that little bit is called Rn of x. So this is nth degree Taylor polynomial of f at a. And so, there are some theorem which about Rn. All right, there are some theorems about Rn. And this Rn's, there are some theorems about the remainder, the nth remainder, Rn. A very famous one. Well, I tell you where to look for it. If you look at the book, the section, here is the remainder first introduced. Turn to the other page. Here is 2 theorem, and on the margin here, there are 2 important results. And I announced Derek Smith's informal reading class at the beginning of the semester. Right? They're reading a book, and recently they're talking about this remainder thing. So there's a well-known result under certain kind of circumstances. This Rn can be represented in the following way. The first thing is called Lagrange formula. Lagrange formula for the remainder. And this is a well-known one. So Lagrange is one of the great mathematicians of that era. So Lagrange form of the remainder goes like this. Rn of x is equal to, and this is very peculiar. If I stop at, you start from this term and you stop at the nth order term, that would be what? That would be this guy, is that right? N factorial. Right? That's a term